I'm Jill Boyce. I'm representing Intel, and I'm happy to host this panel discussion. It's a different type of format this year, but we have a great group of panelists with us that are representing some of the leading companies in the deployment of AV1 commercially. So we have from Amazon, we have Yushi Shen. From Facebook, we have David Ronca. From Google, we have Matt Frost. From Netflix, we have Andre Norkin. And from Tencent, we have Shan Liu. So the format that we're going to use today is give each company is going to give a little bit of an update on their own company's implementation of AV1. And I'll give a little update of some of the companies that are not represented here of the update. Then we'll move into some Q&A where I have determined the questions. And then we'll go to the audience Q&A. So there should be the people that have joined, there should be a link that you can submit your questions electronically. And we hope to about halfway through shift to audience questions. So last year we had a fairly similar panel to this, but at that point everything was with AV1 deployment was really just getting started. And this year there's just been so much more progress. So I think it's going to be very exciting to hear a little bit about this progress and see where we are. So let me speak for a moment about what Intel has done in this area. Pretty recently an announcement was made that Intel has hardware coding in some of our upcoming products. We announced for our integrated graphics and the new Tiger Lake CPU, as well as in a discrete graphics card that's called DG1 that is coming. And so we have dedicated hardware acceleration to be able to do AV1 decode. In addition, within Intel, on the software side, the SVT-AV1 open source software encoder, which was designed by Intel and Netflix, has been decided to be used by the Alliance for Open Media's software implementation work group. And it provides a real-time software encoding of AV1. Going now to other companies in the space, there have been a number of product announcements from a variety of companies. Hardware decoders, we've had MediaTek, who's announced a smartphone SoC, and both Broadcom and Realtek have announced set-top box SoCs. NVIDIA has announced hardware decoding in a CPU. We have some televisions from Samsung and LG that can do AV1 decoding in hardware. And we have mobile phones from Oppo and Vivo that have been announced that have AV1 support. And I think we expect to see even more announcements coming forward shortly. So now let me go let each panelist introduce themselves and say a little bit about what their own company is doing. So first, Yushi from Amazon.
All right, thank you very much, Joe. Good morning, good afternoon, good evening, everyone. My name is Yushi. I'm a principal engineer with Amazon, AWS, and Twitch. In the next 1 minute, I'm going to talk about AV1 activities at Amazon. So above everything, Amazon believes that AV1 is a key technology in the 5G area that's going to bring new user experience to our customers and to our community. So one example I'm showing on the screen on the left is a QHD 1440p 120 frame per second gaming content demo. And we are also going to publish more detail about it in the near future. So in order to deliver this new user experience, like higher resolution, higher frame rate, we are working on multiple aspects of the ecosystem. In order to make AV1 a viable codec format that we believe can widely replace H.264 in the future. So these areas including decoding, encoding, and content platforms. From the bottom, with regard to decoding, we are working with SoC device and software vendors to accelerate the penetration rates of AV1 decoder support, which we believe is a key factor that determines the commercial success of AV1. On the other hand, on the encoder part, in March 2020, AWS Elemental launched AV1 support in the Media Convert, which is our cloud VOD video transcoder. And to connect the encoding and the decoding technical stack together, the AWS Media Service team is working towards offering AV1 in their turnkey streaming solutions. And Twitch, as a content platform, is looking at streaming AV1 to its gamer community. In fact, as also mentioned, Joe mentioned in the previous slide, you might have heard from the recent NVIDIA's RTX 30 series GPU press release about Twitch's plan of supporting AV1 in the near future. All right, thank you very much.
Great. All right. So then now let's go on to David from Facebook.
Hi, I'm David Ronca. I work at Facebook. I'm on the video infrastructure team. And we're actually really excited about Facebook. It's giving us an opportunity to reduce the video egress bits, which has actually been a real challenge over the past few months with the increased use of video through the COVID crisis. And it's also allowing us to push our quality forward at the same time. There have been recent improvements in the software decoders, and especially in SVT AV1, that have really brought AV1 into the practical domain where we now see we're actually able to run encodes in production, and so we're beginning to work on a rollout strategy there. And we've been running a large-scale decode test across a set of mobile devices so that we're beginning to understand the levels of performance we can get from the devices when we finally roll out AV1. And anyway, so we're excited about the opportunity, and we're excited about bringing AV1 to some of the great new Facebook video products.
All right, thanks. And now let's go to Matt from Google.
Thanks, Jill. As Jill said, I'm Matt from Google. I'm a product manager on the team in Chrome that works on developing media technologies like AV1 and its predecessor, VP9. We have been using AV1 for quite a while, actually. We first introduced it in YouTube in the second half of 2018, and we are using it from the very lowest resolutions to 8K content, which some people with the high-end, most recent LG and Samsung TVs are using. Earlier this year, we added support in Duo, which is Google's consumer video conferencing application. And we have, obviously, like all video conferencing applications, it's seen a lot of use during the pandemic. And we've already gotten very favorable results from our experiment with AV1 and Duo. And all of this we're able to do because of the introduction of AV1 in Chrome and Android, which gives us, with Chrome, access to 1 billion endpoints, with Android, starting in software, access to several billion endpoints. And I think like the others here, we're looking forward to introducing it into the whole range of Google's video applications and services.
Okay, all right, thank you. And now let's go to Andre from Netflix.
Hi, so I'm Andre. I work for the Netflix coding technologies team. So as you probably know, Netflix is quite invested in AV1. We believe that AV1 is the technology that can bring new, better experience to our members. As you probably know that we have been streaming AV1 since February 2020, which we announced in one of our blog posts. Currently, we support AV1 on Android devices, and we use software David decoder, which is a pretty fast decoder for that. So what we see is that we are getting better quality or lower bit rates compared to the VP9 mobile encodes, which is a similar encodes family. Currently, we are testing AV1 on other platforms and certifying other platforms, which also includes the hardware decoders. That's basically what I can say on this point. And I can just say please follow our tech blog. We will announce more concrete results when we are ready. What I can say right now is that we are planning to use 10-bit encodes across all devices. We are not going to use 8-bit AV1. Also, there are some efforts ongoing in the company to increase the reach of AV1 so that more members could enjoy the benefits of this new technology. The last point that I'd like to talk about is AVIF, which is an image format based on the AV1. And you could have seen our blog post from February this year, where we compared AVIF to the other image formats, and we found that its performance it's better than most of other image compression formats out there. So I can say that we will start testing AVF in our application UI. Thank you.
Okay, and next let's go to Shen from Tencent.
Hi, good morning, good afternoon, good evening, everyone. My name is Shan Liu, and I am from Tencent. Tencent is a global leading video game company and one of the largest social media and internet companies in the world. Its services include games, social networks, entertainment such as music and video streaming, e-commerce, payment systems, and many other internet services. I am a chief scientist and general manager of Tencent Media Lab, where we build multimedia technologies from research and standardization to products and turnkey solutions. While Tencent makes many different types of products and provides a variety of services that's listed in the slide, video compression is indeed one of the key competencies behind all these businesses, and therefore the company is very active in research and development and deployment of advanced technologies. Since Tencent joined the AO Media as a board member in last October, we have launched AV1 transcoding service on Tencent Cloud. That was in last November. About a month ago, Tencent Video started supporting AV1 as one of the transcoding formats for its VOD service. We're actively working on AV1 software codec optimization together with other companies, including Intel, Netflix, Google, Facebook, and many others, hoping to bring it to more applications in the near future. We, of course, would also like to see more AV1 hardware support, which would further open the door to more low latency and real-time applications, even ultra low latency applications such as cloud gaming. Thank you.
Thank you, Shen. Thanks to all the panelists for being here. It's kind of too bad we're not able to use AV1 for this actual broadcast. Maybe next year, right? But there's been a lot of progress in the last year. I do want to remind you, we are live here, so please go ask your questions inside of the Slido window. I have some questions of my own, but then we want to get to the audience questions. So let's start out with one of my questions, which is, so what are the use cases that are best suited for AV1 to be using? Let's start with Yushi.
Okay, yeah, thank you, John. Besides all other applications that other panelists has mentioned, so AWS and Amazon content platforms, we are particularly excited about two new use cases, which we believe can bring our customers and the communities new values. The first one is as I mentioned in my introduction slides, the high resolution and higher frame rate video. So AV1 can help Twitch, for example, stream 1440p, 144, 120 frames per second at a reasonable bit rate of 8 to 10 megabits per second, which we believe is quite accessible for many home broadband and 5G users in the near future. So one background is as the 1440p, 140/40 is become the new norm of gaming, to be able to stream 2K at a higher frame rate is a critical capability for Twitch in the next couple of years. So that's one application. The other use case relates to the switch frame feature of AV1, and which we believe that can bring large-scale, ultra-low latency. What I mean is the end-to-end latency of 1.5 seconds So this switch frame feature, we believe, can bring ultra low latency live broadcast experience to our users. And this is particularly useful to improve the interaction between the broadcaster and the audience, actually like what we are doing now. And it has many applications in remote educations, online shopping, and UGC media and entertainment. Okay. Thank you, Joe.
Okay. Shan, do you want to weigh in on that also?
Yeah, thank you. So for AV1, I don't see any barrier from AV1 codec itself that prevents it from being used in most video compression applications, including video on demand, live streaming, or even real-time communication applications. Having said that, in the early stage of deployment, we believe that AV1 will likely start having wider commercial acceptance on VOD applications, because we know that in VOD, typically the uploaded video is encoded just once and then stored in the cloud and distributed to millions of users. And therefore, VOD applications are more looking at the supreme encoding quality or compression efficiency, as the bandwidth cost takes a big portion of the total cost of the service providers. So therefore, the service providers may not be too concerned about their computational complexity or encoding delay, as long as the decoding and playback can be done in real time. But as the encoders are more and more optimized, especially if hardware encoders becomes more available in near future, AV1 can certainly be used in more types of applications and products, including low latency and real-time ones. That's my view. Thank you.
Okay. Matt, do you want to weigh in also use cases from the Google perspective?
Yeah, I'll just quickly point out that, as I noted in my introductory comments, we've been using at YouTube AV1 since the end of 2018, and we've encoded, I think, 40+ million pieces of content into AV1. We are, although we don't break out our numbers, I think we've publicly said that we are streaming 1 billion VP9 and AV1 videos a day. So I know there have been questions in the past about the actual deployability of AV1, and this is a group that we're talking to who really are interested not just in sort of the theoretical gains of a codec, but what they can actually get. And we can say that from the very high end, as I mentioned, 8K, we're using AV1. Certainly for the much more common resolutions at the lower end, we're using it. And then, as I mentioned, with Duo, which is requires real-time encode and decode, we are currently using AV1 to really great effect in Indonesia, India, and other markets.
Okay, thank you. All right, next question. What is missing, or what are the barriers in the ecosystem to support AV1? And when and if do you expect them to change? Let's start with Andre from Netflix.
Thank you, Jill. So I wouldn't use the word barrier here, since basically AV1 is currently in a typical cycle for the for availability of the decoders. This is quite common for any other codecs that has been deployed. So you typically expect the hardware decoders being available in 2-3 years after the codec has been finalized. And before that, usually the software decoders are coming first. And currently for AV1, most decoders are in software, which may somewhat limit the resolution or have a higher power consumption. However, we are currently seeing the hardware decoders ramping up, and so we expect a large hardware decoder population in a couple of years. So on the other hand, in order to have more decoders out there, it's useful for the content providers to actually have some content that these decoders can utilize. And at Netflix, we are trying to create this virtuous circle by making content available early on, both for testing and for streaming, available on our service. And that's what we are doing to speed up this process. Thank you.
Yeah, thanks, Andre. Yeah, it's a little of this chicken and the egg that, without the content, nobody wants to deploy the devices, and without devices, nobody wants to deploy the content. So getting started is the challenge. Yushi, do you want to weigh in on this too?
Yeah, sure. I guess that's probably the biggest topic that we are discussing in this panel and why people are kind of tuning in this broadcast. So as Anya mentioned, that in the past that the decoder ecosystem has been the deciding factor for the commercial success of any new codec, and we believe AV1 is not an exception. For Amazon in particular, we are paying extra attention to the sector of the low end, which I mean is less than $300 mobile devices, because we believe that this is the most important client platform that for the video consumption in the upcoming 5G area. So, related to what Andrew has mentioned, on one hand, we have been seeing great progress on the AV1 software decoder, so both in the browser and Android. In particular, the speed optimization for David and libg AV1, so that's fantastic. So according to Mozilla's recent study, that typically we have seen that AV1 decoding for 1080p 60, 8 bits can be achieved by 3.5 cores of a middle-end ARM CPUs. To just give you another data point, that a Pixel 2, Google Pixel 2 or Snapdragon 835, which is really a 3-year-old phone or CPU, already has 8 cores. So that's one side. The other side, of course, the battery life is another key factor for the feasibility of AV1 software decoder. So at this moment that Amazon, we are working with ARM to do a comprehensive study on this topic. Okay, thank you, Joe.
Okay, thanks. The AV1 has had a goal of being patent royalty free. So how important is that to AV1? David, can you weigh in on that?
Yeah, certainly, and that's a really, really good question. When we think about the web, right? We're here almost 30 years in. All the work that's been done in HTTP, HTML, CSS has all been done through broad collaboration amongst many companies, and the results have been a very robust and royalty-free web ecosystem. I mean, this model has worked really, really well. We believe that video now is so pervasive and essential to the web that we need to move video in this exact same model. That it's going to be really hard to move web video forward if it's encumbered by confusing licensing and royalty models. And the best way to go forward is a royalty-free open codec. And indeed, the hypothesis of the Alliance for Open Media when we all started was that the need for a open and royalty-free codec, video codec, was such that many companies would be willing to invest their time, their talent, and their treasure to produce these high-performing royalty-free codecs. And so, yeah, we think it's critical, and it's important that AV1 is open, it is royalty-free. Thank you.
Yeah, Matt, you want to add anything?
I think David put it very well. I guess that the thing I would remind people of is, one, we're just coming, we hope, out the other side of a pandemic where I think all of us are reminded of how important these free video conferencing applications that we're all using are. And these can only be built with codecs that can be deployed without expensive royalties to patent pools. And as David also said, this really is about just certainty when you're building devices and building products that are using these media technologies. You need to know what the terms are. You need to know what you have to pay. And that's one of the real benefits of open source and royalty free, is that the terms are laid out there for people to understand before they deploy. And finally, I'd say, Yoshi was talking about Amazon's focus on lower end devices, $300 devices and below, which obviously are incredibly important for next billion users. And you can't build products like that if you're layering expensive media technology upon expensive media technology. So to make sure that everybody around the globe has access to the very best media experiences in video conferencing, we need to have technologies that, as David said, can be deployed for free.
All right, thanks. Actually, that's a good lead into my next question, which is really about deployment, where you've seen a lot of progress on AV1 in the last year. But when is it going to really ramp up so that we're going to have really large volumes of users? Ayushi, do you want to comment on that?
Yeah, sure. Yeah, thank you. So as I mentioned that we are doing studies, I think everybody is doing studies, particularly for the AV1 software decoder I was talking about. We know, we have some ideas about its performance. We also do some study about its battery life. If that turned out to be a feasible solution on ARM CPUs, we expect AV1 will get widely deployed on desktop and mobile devices for UGC application first in the next 2 to 3 years. Furthermore, also as Andrew has mentioned, as more hardware AV1 decoding become a reality, PGC DRM protected content will also be streamed in AV1. So for AWS IVS and the Twitch, for our point of view, we anticipate that we are starting to stream head content in multiple formats. What I mean is H.264 plus AV1 in the next couple of years. But as more and more AV1 decoder become available, we also anticipate that our tail content will almost be streamed entirely in AV1 in the future.
Okay, Shan, can you comment also?
Sure. So we've already seen a few internet companies have already adopted AV1 as one of their video codec solutions, including Tencent. And a few hardware companies have announced their AV1 hardware decoders, and I believe more companies are working on it and or have it in their roadmaps. So if I would guess, I wouldn't be surprised that AV1 is has its presence in most major video applications in a couple of years' time. And with the hardware decoders being available on more platforms and more devices, and I think AV1 might have its flourish in, if I would guess, then my personal view is about 2025. So hardware decoders are very important, and Yushi just mentioned that they serve some not so high-end mobile devices, and Tencent serves a very wide variety of customer groups, from high-end to medium-end to quite low-end and old mobile phones. And we even provide cloud gaming services to run it on very low-end phones. And so hardware decoders are very important. Thank you.
Okay, thanks. Recently, the AOM, the Software Implementation Workgroup, announced that it would use the SVT AV1 software as a reference production encoder for AV1. What benefits does this bring to the ecosystem? David, can you comment? Facebook's been actively involved in this effort.
Yeah, of course. Well, first of all, the reason that we decided to kick off or launch and form the Software Implementation Working Group is we did feel that one of the things we would like to have done better in AV1 is the lag time between the spec adoption and actually having a high quality production grade codec. So we felt for AV2 we want to get in front of that and then make sure that we're getting that work done so that we can actually reduce the time to market for AV2. But at the moment, the SIWG, or Software Implementation Working Group, is focused on AV1 and have a very ambitious roadmap, with SVT AV1, which is the codec that we've adopted as one of AOM's official codecs. We have a very ambitious roadmap with that, and just really making SVT AV1 one of the best encoders, and I mean not just the best AV1, but really in terms of both complexity and efficiency, we want SVT AV1 to be even a strong competitor to HEVC and VP9, so that even at the low complexity area where we're using much less CPU, we believe that AV1 will still be the better codec for the use case. And so we're actually currently collecting requirements around that, the use cases that are going to be important for SVT AV1 for the next year or so. We're looking at the we're looking at a low latency VOD use case, looking at platforms, which platforms we want to port SVT to, and these are just some of the great ways that we're moving forward with codec, and we're very, very excited about the opportunities that SVT AV1 has actually brought in to the ecosystem.
I'm going to go to Andre, but first follow up with David. There was a question on the questions saying about, I hear AV1 takes a long time to encode. What do you think?
Well, it did, right? And guess what? HM takes a long time to encode, right? And so if you think of AV1 libaom when it rolled out 2 years ago, a good frame of reference might be HM or a reference encoder. This has now been 2 full years, and both libaom and SVT have the teams have done incredible work at optimizing these codecs, and so you're actually now seeing if when you compare the codecs, and by the way, the Intel SVT team did discuss the results of their comparison that they've done recently, which was complexity versus efficiency, and you're seeing that SVT AV1 actually is a very strong competitor to X265 at the higher speed. I'm sorry, at the lower speed settings, the higher quality. So SVT AV1 is delivering a higher efficiency at a significantly lower compute than X265 slow and very slow. So we're really seeing AV1 emerging as a good, solid, and performant codec, and many of these performance issues, which were true, they were there, they're now being resolved through really great engineering efforts from the SVT team and the Google team and the rest of the companies that have been working on AV1.
Yeah, thanks, David. Yeah, some of my Intel colleagues working on the SVT AV1 have done a great job, and this paper you're referring to was in SPIE is published. Andre, also Netflix has been very involved in SVT AV1. Anything more you can say?
Thank you, Jill. So David gave a pretty good and detailed answer regarding how the SVT AV1 is going to be used in SIWG. What I could add on that is that adoption of SVT AV1 by the SIWG group, it's a milestone for our joint project with Intel that we started about 2 years, actually almost exactly 2 years ago. And one of our goals was to create a platform that can be used for easy experimentation on the new encoding technologies. And I think that adoption of the SVT AV1 by the SIWG hints at that we achieved this goal. And I think that SIWG can first of all use the SVT AV1 to create even better encoding algorithms for AV1. And as the second goal, you can also use this platform to test some new video coding tools and hopefully have a production encoder for the new codec earlier, soon after the codec is finalized. Thank you.
Okay, Andre, while you're talking, let me stick with you with one of the audience questions, which is, why has Netflix decided to go exclusively for 10-bit encoding with AV1?
So basically, one of our motivation was that if you think about 10 versus 8-bit encoding, so you see some difference in software. So it's typically you can get a faster decoder in the software. However, we expect in the end to mostly have hardware decoders, and the main profile of AV1, it includes both 10 and 8-bit encodes. So, and 10-bit encoding gives you some advantage in the compression efficiency. So for us, it just makes sense to use the more efficient or more higher performant profile, or let's say, depends on what you call the profile. There is just one, but generally you can get some benefits in coding in 10 bits.
All right, thanks. Here's one from Matt. It says, Google Duo use case seems different than most other applications which are VOD. Any specific challenges or benefits for using AV1 in this use case?
Yeah, so I think certainly the challenges are that when you're doing a software-based video conferencing solution, you have to do simultaneous encode and decode, which really puts a lot of pressure in terms of power consumption and CPU consumption. I think what it also shows is something about the complexity of AV1, which is we can do simultaneous encode and decode. We are not using all the tools that we would use if we had hardware available, and so it means that we are not getting as good gains as we will when we finally have hardware. But we, as I mentioned, are still seeing really good results, in particular for people in the most challenging bandwidth conditions, so mobile networks in Indonesia and India. And I think it does two things. One, it showcases the compression efficiency of AV1, and it also, I think, puts the lie to the story of AV1 as being just incredibly high complexity, because even in software, even doing simultaneous encode and decode, we can get a really good result with AV1.
In VVC version 1, AV1 has already been deployed in quite a few places, including Tencent Cloud and Netflix and many others. So, and we know that in terms of compression ratio, AV1 is roughly halfway between HVC, VVC. It's both in compression ratio technically and also in time frame. I think they are, I wouldn't really think they are head-to-head comparison. Besides, there were so many different applications, and each codec has its own characteristics, and we have different needs, both technically and geographically. And we have been living with multiple codecs for many years in the past. I wouldn't be surprised that we have more than one active codec in the market around the same time.
Okay, anyone else want to jump into that? Again, it's about, was asking about VVC and asking just also about outside of internet, but in terms of more traditional cable broadcast distribution.
Yeah, I mean,
at least say for myself.
Sorry.
Go ahead, Matt.
Well, I was just going to say, certainly we are very open to supporting the broadcast industry. It hasn't traditionally been a place that we've targeted because all the companies represented here, and I think mostly the companies who participate in AOM are web video companies, but obviously there's such an intersection now of web and broadcast, and the core compression technology is pretty much the same. You know, historically there was this issue with interlacing or deinterlacing that you needed for broadcast, but even that's less important. So I think we're very open. We built a great technology. It's certainly useful for broadcast. We just haven't focused a lot of effort to getting into broadcast. But obviously, we're being supported in hardware on set-top box chips and in TV chips and in a lot of device chips that could also support broadcast video.
Okay, thanks. Actually, this question, it says, what's the latest progress on reducing AV1's power guzzling, and how long before you think AV1 becomes commonplace on smartphones? I think we have seen a few announcements on smartphones, but anyone want to weigh in on this?
I'll give a quick answer on that because one of the things we've been doing at Facebook, we're actually running an extensive device survey. We have a partner of ours, and we're going to be testing hundreds of Android devices, really kind of trying to determine the capabilities with the AV1 decoders and so that we can understand our opportunities. And what we're seeing is, initially, again, the perception that AV1 was slow and complex, both from encode and decode, was, not without merit, but that was because they were the people were looking at tools that were functionally complete but had not been optimized. And so what we're seeing is even, we're testing the existing deployed AV1 decoder in Android phones, for example, against the latest GAV1 and David, and the performance improvements we're seeing are stunning. And so there is an opportunity to bring AV1 in, and that opportunity is sooner rather than later. We are looking forward to broad deployment of hardware. We think that's even going to make the AV1 opportunity larger, but we see that there's going to be a big opportunity to use AV1 in the ecosystem, even using the software decoders. And so I think the answer to that question is, well, the perception of AV1 being a resource hog was correct only because we were looking at kind of reference grade tools, not production grade tools. With SVT AV1 encoder, with libaom encoder, and with the David and GAV1 decoders, now we're seeing very, very solid implementations, and most of those performance issues have been resolved.
Yeah, I would like to second David's statement. Like at Amazon, we are doing similar research, and we have also seen great performance result. As I mentioned, like for 1080p60, we believe that even middle-end mobile phone can decode without any problem. So the further data we are collecting is about the battery life. At the moment, I don't really have any concrete data to offer, but hopefully soon that we can publish some result.
Thanks. Anyone else want to add on? I can go on to the next question. This question, all right, this is a bit of the elephant in the room, but it says, how does the recent CISFEL assertion of AV1 IP impact decision-making and concern about royalty-free? Matt, can you try that one?
Yeah, I mean, I think that's really a question for the lawyers. What I would say is that all of these companies here, other companies that participate in AO Media, got together specifically with the goal of developing and having a process around ensuring a reliably royalty-free codec. And we worked together to do it, and notably, none of the members of the CISFEL pool were participants in development of AV1. And I would say that we're all here talking about our plans to deploy AV1, which I think says a lot about the process that we undertook.
Okay. This just while we're on that question, there's just other questions somewhat related, and it says, what would you say to people who say the royalty-free model is disingenuous because there are hidden fees?
So again, I guess I would say that we certainly have developed a process. We have a bunch of very sophisticated companies with very risk-averse lawyers who tried to develop a process to ensure that we were building a royalty-free codec. There's any technology we use bears some risks, and I think there are many suits around standards-based codecs out there. So certainly we very much do the best that we can, and we think we have a very good process for giving us certainty.
Okay, thank you. All right, here's another question. It says, because of complexity, do you think the need of AV1 encoder or transcoder is there? If so, what use cases and when? Not sure if I fully understand the question, but again, need for encoders and transcoders.
Yeah, Jill, I feel like this is continuing. Again, I will going to kind of sound like a broken record here, but the concerns raised with regards to AV1 complexity were legitimate, but the evaluation was being done on software that was not optimized for production. It was optimized for codec development and research. And so I will say that, for anybody who's listening to this, look at the results, the Intel results that were presented at SPIE. Look at the results that are coming out for the David and GAV1 decoders, and I believe that the opportunity for AV1 is large. The complexity issues are being resolved through good engineering, and I don't believe complexity is going to be a hindrance to deployment of AV1. I know certainly for Facebook it has been a concern, but as the tools have made so much progress so fast, we're now seeing the opportunity for us to actually revise our roadmap and accelerate deployment of AV1.
I make a comment about this topic also to second David's statement. I think the complexity, I mean, my understanding about this question is there's a complexity in the encoder. But from the data we have seen from the market, that the complexity of the decoder is more or less manageable. So, and also as you can see that all these products that has been released to the market, decoder always comes first, which means that the consumer encoder might come a bit later. In this sense, that a backend based transcoder is it will be a quite useful capability. And as a matter of fact, that the AWS is so we are in a position to offering multiple transcoder products to the market in order to provide the user the best experience. So I do want to second David's statement that there is opportunity to do backend based transcoding so that we can bridge between the previous codec format to AV1.
I want to weigh in on this one myself. Mostly I'm the moderator. I'm trying to not answer the questions, but I feel like I need to weigh in on this one from Intel. My colleagues in the Open Visual Cloud activity are doing encoders and transcoders, and there will be use cases where user-generated content, people don't have AV1 encoders. They have ABC encoders or HBC encoders, and the deployment of decoders, hardware decoders, is going to be faster than the deployment of hardware encoders. It's just kind of by its nature. And so there is certainly going to be the need for cloud-based transcoding. And as Yushi said, Amazon is rolling out something, and Intel, both the SVT AV1 and just the Intel products in the Visual Cloud can address that encoding and transcoding use cases.
Jill, can I weigh in
Sure.
on this question? So as it was mentioned earlier by other participants, there is decoder and encoder complexity. So the decoder complexity seems to be manageable, and the encoder complexity, you shouldn't take it as one point, but it's rather a continuum of different operating points for the encoder. So, and different companies can choose different operating points. Like, for example, in the video on demand use case, you can spend more complexity on the encoding to get lower bitrate or better quality. In some UGC content, you probably prefer operating on the somewhat lower complexity, and you'll get maybe less of the benefits in terms of the compression. So obviously, what it seems like for AV1, you can get, let's say, more compression benefits compared to some older formats. And if you have, let's say, cycles to spend on that complexity, it may be a good choice. And it seems like, for example, it's a good choice for us.
Right. Yeah, I mean, I think we're going to be seeing certainly hardware-based encoders moving forward. I work for the part of Intel that makes hardware encoders and decoders that get included with Intel products, and so certainly will be coming at some point in the future. We've announced the decoder, but encoders will be coming, and we have the SVT AV1 now. Okay, all right. All right, here's another question. Do you see AV1 being the sole codec at some point and have almost universal deployment and replace H.264 AVC? And when do you think this could happen?
I would just say that we've been hearing about the death of H.264 for a very long time. And so, as Mark Twain once said, the news of the death is grossly exaggerated. I honestly, it's hard to see. I mean, we keep wondering, this humble little codec that's 20 years old is still kind of going along. We've never had a single codec world, and it's hard. I just couldn't imagine. I won't say, I never say never on anything, but it's hard to see looking in the future and seeing one codec, right? It's never been that way. The codecs often have use cases they excel at. There's different ways they're used, and so I don't really see that changing as far as like the trends, the things that we've seen historically with the video codecs. There's always been a couple that are being used for various use cases, and I see that that's going to continue. I think the real question for all of us is when is H.264 actually going to get deprecated, because thus far it's still the dominant codec in the ecosystem.
And I think, as David said, I feel it's like the two sides of the coin. On one side, that H.264 always legacy codecs, that's all the like traditional applications will continue to use H.264. It's quite difficult to get rid of it completely. On the other hand, I think in our opinion, that all the new use cases or the new application we believe that AV1 is the format that will deliver these, particularly in the 5G area. So I think for those 2 points, that we believe AV1 is the newer format that will replace H.264 for the new experience.
It's for our use case, it's difficult to talk about a single codec because we need to support a multitude of different devices, which sometimes have been deployed years ago. So probably we would still need to stream some older formats, like H.264 is pretty common nowadays, so to the older devices. But we would expect probably AV1 to become more dominant in the newer devices. But like for our service, it's difficult to say that we would just stream one format, because we really want to support all of the applications and devices that we have out there.
Go ahead.
Others, I would love to say that being universal and being the single codec, being single, there are slightly different concepts, and we could have more than one codec being universal, and the world is very big.
Yeah, that's true. I mean, it's a necessary but not sufficient condition that it be deployed on a wide amount of devices. But I think we do live in a world. Go ahead, Matt.
Sorry, I would just offer maybe maybe not a contrarian point of view, but I think that a challenge that we face as a community, it is important to think about whether we can come to a point where we can deprecate, as Yoichi said, deprecate an older codec and move up to the next generation codec, because otherwise the $300 devices or $200 devices we want to build are just going to keep getting more and more expensive because of silicon costs.
Well, like what time frame?
Well, I mean, if it's so not, I guess putting my partisan hat on, if you look at VP9, for instance, on Android, I think VP9, which is a codec that was released in 2013, has very strong penetration in hardware all the way down Android device types. And so that's 7 years with a less concerted effort than I think the AOM community has had behind AV1. So, I mean, and obviously another challenge historically has been a divided ecosystem where you have iOS that's supporting different standards than Android is. And obviously Apple is an important member of AOM, and I think we'd all hope that at some point Apple devices will support AV1 as well. So maybe, Shan mentioned 2025, maybe 2025 will be 7 years after we release the AV1 standard. So maybe that's a point when we can start seeing AV1 support and hardware that's sufficient with backup and software that we could start thinking about this, maybe earlier.
Okay. Thanks. Okay, it's a question. It says, is the new AOM IWG testing or considering testing LCEVC, which is, I guess, the MPEG low complexity, what's it stand for, LCEVC, low complexity something, alongside AV1 as a method for reducing computational complexity. Can anyone?
Yeah, I mean, it's a good question, and the answer is no. Really, the mission of the SIWG is to focus on production-grade implementations of AOM codecs, which are by definition open and royalty-free. So at this point, the SIWG has a single focus, and that's continuing to improve AV1 and help fill in the missing pieces in the ecosystem, the AV1 ecosystem. And as AV2 research and testing begins to move forward, the SIWG is also going to work to provide, as AV2 tools are beginning to stabilize, the SIWG will provide production grade implementations of those tools to allow further iterations of testing. But no, at this point, there is no point. Our mission and charter is a focus on the AOM royalty-free codec standards, and so we would not be doing an implementation of VVC, HEVC, AVC, or LCEVC.
Okay. One thing, actually, though, although AVIF, we mentioned that that is something we are working on, and so that's putting kind of AV1 in a wrapper to be used for image formats that have been designed elsewhere. So, can anyone comment about that? I mean, Andre, you had a comment about Netflix doing some work on AVIF.
Yeah. So, as I mentioned, we had a comparison of AVIF with other image coding formats in February. Yeah, I believe February this year. So we see that AVIF is very competitive with other codecs that it has been testing against. And yes, we are planning to test AVIF in our user interface. I guess that's what I can say about the current status of that. What I could add is probably we have seen that AVIF can be quite efficient in coding images which are like typical images for the user interface. Like, for example, if you have kind of a billboard for a movie and then some text on top of that, and typically you may have problems in coding such images with a good quality with JPEG. So that's one of the areas where AVIF can show benefits.
Matt, I think Chrome has had some announcement about AVIF.
Yeah. I think we announced fairly recently that AVIF was added as a supported format in Chrome. And at the time, Chrome was talking in particular about things like support for HDR, just general performance improvements that allow for faster page loads for image-intensive web pages. So it's something that we're excited about, and I know the Chrome team is already talking to some partners about testing AVIF.
Okay. We're running out of time. I have one last question, which it's I think we talked about it. It says, you know, here we kind of address this a little bit, but I just want to talk about encoders. It says here AV1 takes a long time to encode. What do you think? And David has kind of addressed that already, but I just want to expand it a little bit to just say, what is the roadmap for SVT AV1 in AOM and in the software implementation work group? David, can you comment on that? What's the roadmap?
Yeah, and I'll reference back to the work that Intel did, the study that they released in SPIE. And if you look at the faster speeds, you see that SVT AV1 is actually delivering roughly equivalent, its fastest speeds at like speed 5 and 6, equivalent complexity or efficiency as X265, very slow, but it's a significant reduction in computational complexity. And then from there, as you use the slower speeds, SVT AV1 just gets better and better towards ultimately about I believe about 29 or 30% better. And so, but what's the interesting opportunity we believe is at the faster speeds, and so that's one of the things that we want to look into is, can we make SVT AV1 even faster? And of course, as you get faster, the efficiency is going to drop. But as long as we're more efficient and less computational complexity than for example X265 or libVPX, then we're delivering more and more value. And so ideally, we'd like to have SVT AV1 as a codec where you can have, if you're focused on, you just need the absolute highest efficiency and you're not concerned about complexity, you turn it all the way to slow or very slow. But if you really need to get stuff done fast, for example, UserBot is a good case where you have so many videos upload, but you still want to leverage the benefits of SVT or of AV1, then you can go to the very fast speed settings. You're still delivering efficiency that's better than the current generations codecs, HEVC or VP9, and you're doing it at a significantly reduced complexity. So we just see there's a huge opportunity to work on with SVT AV1, and that's some of the focus. That's going to be a lot of the focus of the SIWG over the next year.
Okay, all right. I mean, I think we are at time here. We have used our hour, so I think we'll stop there. Thanks everyone so much. Thanks to the IBC, and thanks to the panelists, Yushi, David, Matt, Andre, and Shan. And I think we're finished then. All right.
Thanks.
Thanks, Jill.
Thanks.
Bye.
Thank you very much.
Everyone. Hope you learned something.